Hi, I'm Matt, the creator of SimpleUI. SimpleUI is a closure web stack that uses macros and an extended HTML syntax to deliver web apps via small snippets. By combining new and existing closure technologies, we get a powerful way of delivering software and driving up closure adoption. Let's start with a quick look at the essence of SimpleUI. Here we see a very small component that displays someone's name. It looks a lot like a closure function because it is one. When we first render a page, we invoke it as a regular function to return plain HTML. Later, when the component updates, we expose it as an endpoint so that we can directly send its new state. The genius behind SimpleUI is the creator of the extended HTML syntax, HTMX. Carson Gross is kind of like the Rich Hickey of the front end. He officially released HTMX in 2020 after building off earlier work. To understand what makes it so powerful, let's take a step back and look at the history of web development. Here we have a screenshot of Tim Berners-Lee's World Wide Web browser that he created in 1993 to share particle physics data with his colleagues. And here we have a screenshot of a modern web page in 2024. Isn't it amazing how far we've come? What I find interesting about the contrast between these two web pages isn't how different they are, but how much they remain unchanged. HTML is still just a souped-up Word document with links. It's true we can produce amazing visuals, but when we want complex dynamic functionality, HTML alone won't cut it. And the first thing that programmers reach for is HTML's evil cousin. JavaScript started off as a simple scripting language only to be used in moderation. But with the advent of rapid browser runtimes, it has grown and ballooned, and nowadays web developers spend a lot of time programming against JavaScript APIs, rather than creating content on the server. Broadly speaking, you can divide web development into two generations. The first consists of traditional web servers that return HTML with just a garnish of JavaScript. And more recently, we've seen the rise of the single-page application. A JavaScript program constructs the page from within the browser. Every time you want to load in a page, you have to download an entire program. What Carson Gross's insight has been is to realize that there must be another way. If the version of HTML that we have is not powerful enough, why not create such a version? Once we do that, we might not need JavaScript anymore. So how can we do it? When we look at vanilla HTML, we see it's made up of many different tags. There's about 115 tags in total, but there are two special tags that stand out: links and forms. Why are they special? Because they trigger an HTTP request to the server, and whatever it replies with becomes the content of a new page. What Carson Gross's embedded HTMX syntax does is enable any element to trigger such a request. Simply annotate it with hxget. Rather than the server reply forming an entire new page, it will only replace the element that triggered it. Let's try clicking on my element. It'll submit a request to my new div endpoint. If that endpoint replied with, say, this div, it would replace the first one. In this example, the replacement is just plain HTML, so no further updates will take place. But if we keep annotating our reply, we can allow as many updates as we like. Suddenly, we're in a world where we can dynamically update content without needing to write any JavaScript. And that's where SimpleUI comes in. HTMX provides us with a syntax, but it doesn't actually generate any content. This is the SimpleUI equivalent of the previous HTMX example. We display a div that starts off saying, "You have clicked me 0 times." The hxget attribute points to click counter, which is the same as the name of the component. This provides a way for the component to update itself and increment the number of times you've clicked it. Let's take another example. This is more like the demo shown at the beginning. We have a greeting component and an input element that triggers an HTMX update. In the clicking counter example, we triggered updates by clicking on the element. Here updates trigger on the input blur event. So you select the input some text, and when you focus elsewhere, the input knows you've finished writing and it triggers the update to greeting. Most page elements trigger on click, but you can always override the default by specifying the HX trigger attribute. For example, we could set a delay on the input element. This would cause it to periodically fire off updates, which might be useful for something like an autocomplete dropdown. Here's how we do infinite scroll. So we have a tr function that makes rows of a table. The last row contains an update to call the next batch of rows. This is another use of HX trigger, only this time it's set to revealed, so it will trigger once the user has scrolled to the bottom of the page. We can do modals in about 10 lines of code with almost no JavaScript. At the bottom we have a button that opens the modal. It triggers a request back into the modal component, only this time we're at the top of the render tree. The predefined top-level boolean is set to true, and the component replaces the previously hidden modal element with the full modal display. All we need JavaScript for is a convenience method to hide the modal if the user clicks on the background. How does def component work under the cover? It basically expands to an ordinary closure function, but with a bit of extra metadata attached that enables us to expose each component. When we're ready to generate a full page, we call the makeRoutes macro. We provide a function that handles the initial page render, and makeRoutes inspects all the symbols inside to find SimpleUI components. It does this recursively until it ends up with a list of readit routes. The first one handles initial page render, and there are handlers for each extra component that we expose. The readit routes at this point are still just closure data, so we can attach middleware to handle authentication and so forth. For example, if we want page-level authentication, that's supported by the readit syntax. How do we manage state? In JavaScript, it's possible to identify 3 levels of persistence. The shortest lived are variables inside the JavaScript context, which is refreshed with each page load. We can store items slightly longer using session storage, and for permanent storage, we make a request to the backend. The SimpleUI equivalent of JavaScript variables are HTTP parameters. The design of HTMX and the hiccup syntax makes it very easy to embed these within the content of the page. We don't have to assign anything explicitly. The parameters are submitted at the component level, not in the page URL, so they'll be reset when we reload the page, just the same as JavaScript variables. For session-level persistence, we make use of Ring's session abstraction. If our component returns a response map without a body key, SimpleUI assumes it's a session update and assigns it HTTP 204, which will save the session but not change anything on the page. Permanent persistence is very easy because we're already on the back end, so it's just a function call. In fact, when we write SimpleUI components, it feels almost exactly the same as writing ClojureScript functions on the front end, but here we're fully in JVM closure land. You could think of this as a third-generation web app. When web apps transform from first-generation HTML to second-generation JavaScript, the resulting frameworks tried to reproduce a server experience on the front end. For example, with the JSX syntax. Our SimpleUI components, by contrast, reproduce the front-end experience on the back end. You might be wondering, isn't it kind of wasteful to have to round-trip to the server every time you want a UI update? In practice, there isn't much of a penalty to pay. Firstly, modern browsers are very good at recycling TCP connections over different requests. I regularly develop SimpleUI from Asia on a server in the US, and even intercontinental requests aren't that noticeable. In addition, when you have a state change in a full JavaScript SPA, you still need to depend on communication with the backend. When we update a UI, for example, what are we doing? we're typically either loading new content or persisting some kind of state change. In both cases, a front-end app will display some kind of loading banner, or it will grey things out while it pens on the back end. So if we're going to have to pause while we wait for that, why not render on the back end as well? In addition, it's important to note that not all load times are equal. The load time users notice the most is initial page render. SimpleUI is fast because it's only loading plain HTML. In this example, it only has to load 2 kilobytes. And even once we include the HTMX library, the total's only 40 to 50 kilobytes, which is a reduction of 90 to 99% compared to a front-end app. At the end of the day, users don't care what technology an app is written in, but they will notice when things are snappy. It's particularly important whenever you have a sales pipeline. Customer dropout is much lower when pages display quickly. In fact, there's a cool trick you can use if you want to be even snappier and serve content over a CDN. Simply make a static HTML page and include the following 2 tags. The div will fire off a request to your main rendering server and bootstrap you into closure mode while the user is busy taking in the CDN content. This is particularly useful if you're using containers or something with a cold startup time. Having criticized JavaScript so much, you might wonder what role it has to play in SimpleUI. There are still plenty of good JavaScript widgets out there, and it can be useful to include them. Sometimes for something like Google Maps, you actually have no choice but to use JavaScript. Every time a component returns a script tag, it will be evaluated. This makes it really easy to load widgets lazily. And once you're in JavaScript, it's easy to switch back into SimpleUI. For example, we can call HTMX trigger. This mostly wraps up this brief interview of SimpleUI. The last thing I'd like to touch on is why I think SimpleUI is an important part of Clojure's future. I've been writing Clojure for 12 years, and I think its creator, Rich Hickey, is an underappreciated genius. But Clojure isn't growing as quickly as it could be, and one of the key weaknesses is the lack of good UI tooling. ClojureScript isn't that easy to use, and even when you do overcome the challenges of advanced compilation, there is still a substantial bundle that has to be loaded into the browser. SimpleUI provides a way to do away with all that and experience the full, untrammeled power of JVM Clojure. There are other Clojure tools using HTMX, for example, BIF, but what none of the other tools provide is an automated way to route updates back to the UI components that generate them. It's really easy to get started in SimpleUI thanks to the Clojure Kit framework. Create a default Kit project and install the Kit SimpleUI module.